Examples 6 and 7 are the last examples in this section, and they are going to have you construct the function of a polynomial that is given. Okay, in example 6, all you're given is the picture of the polynomial you're interested in, and based off of that picture, you've got to come up with the formula for the polynomial. Okay, and in example 7, there is no picture, but you are given a verbal description of the polynomial, and you have to construct the function. Okay, all right, so let's start off with example 6. Okay, it says, write a polynomial function whose graph is shown below. Use the smallest degree possible. And I'll explain that as we go along. Okay, so when we look at this graph, okay, notice a couple of things. It is W-shaped, okay, so that means more than likely it is going to, well, not more than likely, it means that it is going to be an even degree polynomial. Okay, so that's one thing you should pick up on. It's going to be an even degree because it's W-shaped. Notice the end behavior. It is rising to the left and it's rising to the right. So that means it's going to be even degree, positive leading coefficient. That's what we can expect. All right, but the way to really get this going is to build the factorization, okay? When we did examples 3, 4, and 5, the ones that we had to graph out, the formula was given to you in factored form, okay? So we are going to do that. We are going to build the factored form of the polynomial, and that's how we're going to come up with the function. Okay, all right, what you should notice, okay, in addition to what we've already observed, okay, is that this graph has 3 x-intercepts. Okay, so you've got an x-intercept at -4. Okay, you've got another one at x equals -1, and your last x-intercept, or 0, is at x equals 3. Okay, these are your zeros. Okay, so think about the factorization. Okay, so let's start with x equals -4. Okay, if x equals -4 is a 0, okay, then what is the factor? Well, the factor has to be x plus 4. Okay, why? Okay, let me go out to the side. If x plus 4 is the factor, I have to set that equal to 0 and solve to get the x-intercept. So if I solve this for x, I'm going to get -4, which is the 0. Okay, so the whole idea of doing this type of problem is to relate the 0 to its factor. Okay, so if x equals -4 is your 0, or your x-intercept, okay, this is the factor that it had to come from, x plus 4. Okay, so this is going to be one of the factors. Okay, so I'll put a little column here that this has to be the factor that goes along with it. Okay, in a similar fashion, if you move on to the next factor, or not the next factor, the next 0, or x-intercept, it is -1. Okay, so again, you have to turn this into a factor. Okay, so x minus 1 is going to come from x plus 1. Okay, again, if I took x plus 1 as a factor and I set it equal to 0 to solve for the x-intercept, move the 1 over, whoops, if I move the 1 over, that is what's going to give me x equals -1. Okay, so that is going to be your factor. Okay, all right, so the last x-intercept, or 0, is going to be 3. Okay, so again, you have to think, what factor would give me x equals 3? Okay, well, it's going to be x minus 3. Okay, because if I take x minus 3, set it equal to 0, and solve this, I'm going to get the 0, x equals +3. Okay, so these are our factors. Okay, so to build the polynomial, you need to multiply these guys together. Okay, but before you can do that, you've got to go a step further. Okay, you need to look at the behavior at each 0, okay? So at -4, okay, the graph is crossing, okay? So we're going to have an, we're crossing, so let me write that down. We're crossing here, so it's going to be odd multiplicity, okay? So remember what the directions said. When you build this function, you want to use the smallest degree possible, okay? So we're going to use the smallest multiplicity that we can that is odd. So we're going to say that this has multiplicity of 1, okay? So what that means is your factor will be raised to the power of 1, okay? All right, -1, okay? Look at the behavior at this x-intercept, okay? The graph is touching or bouncing, okay? So that means, since you're touching, that this x-intercept or 0 has an even multiplicity, okay? So again, you want to have an even multiplicity, but use the smallest possible to get the smallest degree possible. So we're going to put an even multiplicity on this one. We're going to use 2, the smallest one we can think of, okay? So in your factorization, you will see x plus 1 squared, okay, because you are touching here, okay? Remember, if you're working, you know, once you do build the function, okay, think about how you would get the intercepts. You would take this factor, set it equal to 0, and solve. You would have 2 x plus 1s, okay, that you would set equal to 0. So you would get x equals -1 as a 0 twice, meaning multiplicity 2, so it would touch or bounce, okay? Last one, at x equals +3. This is the factor. You are crossing here. The graph is crossing. So that means we are dealing with an odd multiplicity, okay? Again, we want to use the smallest possible to build the smallest degree polynomial possible, okay? So we'll use a multiplicity of 1. So this factor will have an exponent of 1, okay? All right, so to build our formula, okay, our function is going to be take the factors and multiply them together, okay? So we're going to get x plus 4 to the first power times x plus 1 squared times x minus 3, okay? You can multiply in any order that you want, okay? Remember, if you do 4 times 5, it's the same thing as 5 times 4, okay? So you could have put this one first, then this one, or this one. It doesn't matter, okay? All right, the great thing about a question like this is you can check yourself. Whatever you got as your formula, you can plug it into your calculator and see if you got this picture, okay? So I'm going to go to my calculator, and I am going to type in what I got as my answer, okay? So I'm going to go to y equals, and I'm going to type parentheses x plus 4 times parentheses x plus 1 squared times x minus 3, okay? And I'm going to even adjust the window so I see the exact same picture that I see, okay? So I'm going to hit window right there, and in the x direction, my smallest x value is -6, my biggest is +6, and I'm putting a tick mark every 1 unit, so that's what the scale is, it'll be 1. In the y direction, my smallest y value is -14, my biggest is +14, and we're going by 2s. Okay, so the scale, y scale will be 2. Okay, that's going to allow me to see the exact same picture that I got. Okay, all right, so we go ahead and hit graph. Okay, and we didn't get the same picture. Okay, if you notice, our x-intercepts are correct. Okay, so like we have a tick mark every 1 unit on the x-axis. So this is -1, -2, -3, -4. So we do have x-intercepts at -1 and -4. And our last x-intercept is at 3. So that's good, but the entire graph should fit in the window based on how we set up the window. We set it up to mimic this picture, okay? So there is one thing, if you were paying attention, okay? If you look at this picture, there's one piece of information we haven't used yet, okay? Yes, we were correct in setting up the function in that we accomplished, we got the correct x-intercepts and the behavior at each one. But our graph has to go through the point 1, negative 8, okay? And nothing that we did in our work has forced the graph through this point, okay? So this initial setup is correct, okay? But what we're going to do now is continue with our work. We're not done, okay? We have to force the graph through this point, okay? This is how you do it, okay? You're going to keep the same work you already have. But to force the graph through this point, you are going to have a specific leading coefficient to make that happen. So we don't know what that leading coefficient is. We need to solve for it. I'm going to call it A, and I'm going to put it out front. We need to solve for this leading coefficient that exists, and it needs to be a specific leading coefficient. It has to be the right number so that our graph gets forced through the point 1, negative 8. Okay, so we're going to solve for the A value. Okay, so now we need to use this point. Okay, we are going to plug in. Remember, f of x is the same thing as y. Okay, if x is negative 1, y has to be negative 8. So we're going to use that information. Okay, so what we're going to do here, and I'll try to color code this. If y is negative 8, okay, then our x value has to be 1. Okay, so I'm going to leave A as A because that's what I'm solving for, this leading coefficient. Okay, and then here, let me set it up this way. All right, so this is what I already have. All right, and now I need to plug in 1 for x. Okay, so all I did was take what I had, okay, put a leading coefficient out front that we need to solve for, this A value, okay, and then I plugged in my point. So wherever I saw an x, I put a 1, and then if x is 1, the y value has to be negative 8, okay. This is going to allow us to solve for the A value, okay. So let's figure out what A is. So we're going to get negative 8 is equal to A times 5 times 2 squared times negative 2, okay. So negative 8 is going to be A times 5 times 4 times negative 2. Okay, so negative 8 is equal to A times 20 times negative 2 is negative 40. Okay, and so now we can solve for A. A is multiplied by negative 40, so to undo that, we're going to divide by negative 40. Okay, so this tells us that A is equal to negative divided by negative is positive. 8 goes into 8 one time. 8 goes into 45 times. The leading coefficient needs to be positive 1/5. Okay, so the final answer to this problem is the equation of, it's the formula for the polynomial. Okay, so I'll write it up here. Here's the answer to example 6. Okay, your function needs to be this, okay, but we need to put in the specific A value that works. So it is going to be 1/5 times x plus 4 times x plus 1 squared times x minus 3. This is the final answer. Okay, so now we're going to go back to the calculator and stick in that leading coefficient, and you're going to see we get the correct graph. Okay, so let's go back to where we were. Okay, I'm going to go to y equals. Okay, I am going to go ahead and insert the leading coefficient, okay, which is 1/5, and I'm going to put it in parentheses. You could also use 0.2 because 1/5 is 0.2. Okay, all right, so now remember I still have my window adjusted to what I need it to be, so I'm just going to hit graph. Okay, and now you can see we get a much better picture. Okay, our x-intercepts are still at -4, -1, and +3. And then if I do that little nifty feature where I hit second calculator, second trace, and I want to know the value, hit 1. What's the value when x equals +1? Hit enter. You get -8, and it highlights that point. Okay, so your polynomial does go through the point 1, -8. Okay, so if you see a problem like this, okay, you have to come up with the formula for the polynomial by building the factorization. Okay, And then if, only if you are told to force the polynomial through a specific point, do you have to add on this leading coefficient, plug in the point, and then solve for that leading coefficient. Okay, so example 7 will be similar. So let's go ahead and try it.